Ladies and gentlemen, good afternoon and welcome to this session in which I'll be talking about unraveling the potentials of Artemisia afra and Artemisia annua as culturally sound alternative therapeutics for the management of malaria. I'm a PhD student, final year PhD student in the University of Liège, and my work is under the supervision of Professor Michel Frédéric in the University of Liège and Professor Gisèle Etam-Lowe, the University of Douala. So, to begin with, let's get some tips on nature's contribution to the discovery of anti-malarials. As we know, natural product serves as source of lead compounds that have undergone chemical derivatization to produce drugs that are useful in chemotherapies. And as we all know, more than 50% of all drugs in clinical use today contain certain substances of natural origin. In the context of malaria, as we know, the examples of seminal contribution of this annual medicine to the world medicinal remedies include artemisinin, that was isolated from Artemisia annua, and quinine, that was isolated from the bark of Cinchona tree. I would like to indicate that artemisinin constitutes part of the combination therapy that is being used for the management of malaria as a first-line treatment, known as artemisinin-based combination therapy. It's also used alongside quinine in some localities. So, despite the use of ACT, we know that resistance has emerged, not only to ACT, but also to other available anti-malarials. And this has increased the resurgent use of Artemisia annua and Artemisia afra, especially in Africa, where the disease burden is at highest. And these two medicinal plants are either used as a decoction or in the form of an infusion as a traditional remedy for the management of malaria. Yeah, despite their effectiveness in the management of malaria and with several scientific reports, both in vitro, in vivo, and in clinical trials, these two medicinal plants are controversially advocated for by several researchers, including the World Health Organization, especially on Artemisia annua. In fact, WHO discourages the use of this particular plant, and their strong statement is that the use of non-pharmaceutical sources of artemisinin will exacerbate the already resistance challenge we're facing with ACT. Continue, please. Yeah. But over the past decade, we've seen that these two medicinal plants has promoted the United Nations Sustainable Development Goals, especially goal number 3, which hinges around health and well-being. To the best of my knowledge, the use of these two medicinal plants should focus on standardizing dosage regimens, understanding preservation methods, quality control, understanding post-harvest handling practices because they impact the secondary metabolite composition and, of course, their effectiveness in management of malaria. It will also be nice to develop pharmaceutical monographs. We are from the field. I'm sure if they show you Artemisia annua and Artemisia afra, morphologically they look alike. So it will be difficult for you to differentiate between these two medicinal plants. So it would be nice to develop pharmaceutical monographs that can be used to authenticate these two medicinal plants. Also, it would be nice to understand how these two medicinal plants interact with the Plasmodium parasite. So this forms the basis of my presentation. So here is a review that was published in 2023. I invite you to take a look at this review. Here we are, where we characterize several secondary metabolites isolated from these two medicinal plants and biological activity, especially on malaria, anti-inflammatory, and immunomodulating properties. So, in part 1 of today's presentation, I will show you how geographical location and season of collection impacts the chemical composition of these two medicinal plants, and of course, their effectiveness in managing malaria. So, we collected samples from 5 different geographical regions in Cameroon in the rainy season and in the dry season. We prepared acetone and methanol crude extract by maceration. We obtained metabolic fingerprints by chromatographic techniques such as thin layer chromatography, high-performance liquid chromatography, and gas chromatography to obtain metabolic fingerprints. And then we analyzed the antiplasmodial activity to see if there will be a correlation between the observed metabolic fingerprints and the biological activity. So, the results obtained were quite interesting. I will begin with thin layer chromatographic analysis. And as we can see in figure A and figure B, shows the terpene composition. Because there is no single mobile phase that can separate all the chemical class of metabolite found in plant extract. So we separated the terpene composition using ethyl acetate and hexane at a specific volume 70-30 respectively. And then we obtained this kind of metabolic fingerprint. And the first observation is that we saw inter and intraspecies variation. And of course, this is important for the development of pharmaceutical monograph. If you look closely at figure B, these are all Artemisia afra samples, and you see that they share the same metabolic fingerprint, except for this sample that was obtained from the east region that had this prominent band, which is absent in other samples. This shows the effect of geographical location on the metabolic composition. The same effect was observed for the polyphenols. So in C and D, it shows the profile, the linear chromatographic fingerprints of the polyphenol composition of these two medicinal plants. And can be seen from here to here is the Artemisia afra, and here to here is the Artemisia annua. And if you compare this region, you see that this medicinal plant also share differences. And so they share variations at this level of the chromatogram. So this again gives us more information that just by TLC, we can be able to distinguish between Artemisia annua and Artemisia afra. So we went further to analyze by HPLC to see, because TLC is not sensitive as compared to HPLC. So we analyzed the polyphenol composition of both plants by HPLC, and we obtained this kind of chromatogram. From this fingerprint, we see clearly differences that exist between these two medicinal plants. And again, this gives us more information on how we can develop our pharmaceutical monograph to authenticate between these two medicinal plants. So we analyzed several compositions, but because I was given limited time, so I will focus my presentation on the contents of artemisinin. So like I said earlier, we obtained samples from the rainy season and the dry season from 5 different geographical regions. We quantified artemisinin by an HPLC UV method after a delimitization step. The first take-home message is that high artemisinin content was observed in samples obtained in the rainy season. So this tells us that season has an effect on the content of artemisinin. And what does this mean? Does it have an effect on the antiplasmatal activity? I think the next slide is going to give us an answer on that. Yes, it is the case, because we can see lower IC50 values for samples obtained in the rainy season. The blue colors is samples obtained in the rainy season. So we see lower IC50 values for samples obtained in the rainy season, indicating higher antiplasmodial activity, and so this correlates with high artemisinin content that was observed in samples obtained in this particular season. So this tells us that when harvesting your artemisia for use as traditional management, especially Artemisia annua, it is important to take into consideration the season of collection. So to get more insights of what I've just explained, that I just one-tenth of the result, I invite you to take a look at this publication. This was published earlier this year in Molecules, where we explore the phytochemical diversity and the antiplasmodial potential of Artemisia annua and afra from different geographical locations in Cameroon. So in part 2, curiosity, because I realized that during my fieldwork, people handle these plants differently. And the way you handle the plants after harvest must have an impact on the chemical composition. And if it's altering the chemical composition, it therefore either increase activity or decrease activity. So it is important that we understand these practices and therefore propose the best practice that can be used in order to ensure consistent metabolic composition and to ensure consistent efficacy. And the good thing about this study is that we prepare the infusions following the traditional preparation method of the plant, how the plant is being prepared traditionally, with the exception that we lyophilize to obtain pure powder that have this color. And then we analyze by HPTLC, this time around not TLC. We analyze by HPTLC, by HPLC, and by gas chromatography. And they also did antiparasitical activity to see if we can find a correlation, because the goal is not to tell someone that, oh, there are variations after the way you handle it, but our goal is to see that there is consistent efficacy. Yes. So I will begin with the result of the thin layer chromatographic analysis, which is quite impressive. Some people argue that artemisinin is not in the infusion, but I challenge you that if you look at B, figure B, we use artemisinin in here as our reference sample, as our reference, and then from the left to the right are our analytes. And from that figure, you see that some samples do not show contents of artemisinin. This shows that the way you handle the medicinal plants has an effect on the artemisinin content. In the case of Artemisia annua, as we know, artemisinin is a potent molecule responsible for antiplasmodial activity. Figure B, A, and C shows the polyphenol composition of these two.
5 minutes for question and answers included.
Okay. So, A and B, figure C and A and C also shows variations in the chemical composition of these two medicinal plants. Here, I show you that the way you dry the medicinal plant also has an effect. And as can be seen, shaded dry shows the poorest of the profile. So it's therefore advisable not to dry Artemisia under the shade, preferable under the sun. So in part 3, curiosity was how these two medicinal plants interact with the plasmodium parasite. Continue, please. And thanks to Dr. Lucia through her collaboration with Professor Manuel Linus in the Hook Center for Malaria Research, Pennsylvania State University, were able to achieve this objective. Continue, please. So we saw, if you continue. Yeah. So if you look at the heat map in figure A, we show that the profile of Artemisia afra differs completely from that of Artemisia annua, which resembles that of artemisinin. So the mode of action of Artemisia afra falls in line with that of artemisinin, showing that the anti-malarial properties of Artemisia annua rely solely on artemisinin. This was further confirmed by nuclear magnetic resonance This was further confirmed by nuclear magnetic resonance, where we show no significant differentiating metabolites found for Artemisia annua and artemisinin, demonstrating their profile as the closest. So I invite you to take a look at this publication for more insight. In conclusion, drying by sunlight improves the metabolic content of terpene and polyphenol composition in both plants, and there is high artemisinin content in the rainy season samples for Artemisia annua. Artemisia afra and Artemisia annua have divergent effects on plasmodium falciparum metabolism, and this provides support for the ongoing effort to identify targets of Artemisia afra for the treatment of malaria. As perspective, it would be nice to characterize the chemical composition of both plants and to understand the mechanism of action of infusion, not only on the asexual parasite, but also on the sexual parasite, and to investigate other post-harvest handling practices on the secondary metabolic composition. I acknowledge my supervisor, Professor Michel Federich. Continue, please. And the laboratory, pharmacology laboratory team members, and Académie de Recherche et d'Enseignement Supérieur for funding this work. And above all, in the room, thank you all for your kind attention.
So it's open for discussion. Thank you very much.
Thank you,
Paula.
Thank you. I read that paper and I really enjoyed it. So it was nice to hear you talk. So I had a question about lyophilization. We lyophilized our water extracts, and then we tried to recover. We reconstituted in the same volume of water. We could never get the amount of artemisinin back that we thought we had in the beginning, that we knew we had in the beginning. So were you able to do that? Because we just stopped using lyophilized extracts because of that. We didn't trust them. So we only use the tea because it works really well, and we just make a 10 gram per liter tea and it works fine. And we can use it for all our in vitro experiments, surprisingly, because we thought we would have to concentrate it. But we don't trust the lyophilized material anymore because we couldn't deal with it. So, curious. Please, expound.
Thank you, Professor, for that observation. We never thought of that. Perhaps on my return, I will try that to see if after lyophilization, it's not possible to recover the same quantity of artemisinin that we have in the infusion as compared to lyophilization. But the main reason why we lyophilized was because we wanted to be able to quantify, because in the infusion it's difficult. We wanted to have the powder to be able to quantify and also to be able to have our IC50 values and to correlate with the content that we detected after the lyophilization. That's the reason why we lyophilized.
Yeah, of course, Romain. I was expecting a question from you.
I would have too many questions, just a comment.
So, one.
Obviously, when you
Switch off.
No. Obviously, when you reconstitute life,
No, it doesn't work.
No, we need that conversation. Okay.
No, thank you.
Obviously, when you reconstitute a lyophilizate, in your smaller volumes, solubilities are not going to be the same. So if there is an insolubility, you should be worried. And if there are no insolubles, it means that there is maybe instability during the process. So that's probably one comment. And regarding artemisinin, it is well known that it's soluble in warm water. It's quite surprising that the amount of artemisinin is pretty consistent in warm water.
Yes, I think it was more of a comment and not a question, which I totally agree.
I totally agree.
10 more minutes. 10 more minutes. 10 more minutes.
Pardon?
On a du temps, on a 10 minutes.
Encore 5 minutes, yeah.
Oui, bien sûr.
So, yeah.
Mine is on the drying. You have said about drying under the sun. Is it under the shade or in the sun?
Yes.
Any clarification on that?
Thank you for that question. I didn't show the data here because of time. We observe for Artemisia annua that drying under the sun gives the highest content of artemisinin. Because there is a precursor, there is in the production of artemisinin, there is an intermediate known as the hydroartemisinic acid. This particular intermediate is produced by photocatalysis. It is driven by sunlight. And I also found reports in literature which corroborate with what we have. So when we dry under the sun, we are sure of high content of artemisinin for Artemisia annua.
Thank you. An inspection to the same. Don't you think that would affect the quality of the product, drying it in the sun?
Like I said, it is research. So our goal was to show that if you dry under the sun, these are the metabolites that are either increased or decreased, and we have to confirm their effects on the antiplasmodial activity. And for the case of Artemisia annua, like I said, when you dry under the sun, the quality of there's high artemisinin content, which is of course our point of interest. And not only that, I did not show the data, also polyphenol composition have also been shown to be increased when you dry under the sun. Let me talk a little bit about shade drying. When you dry under the shade, it takes several weeks, perhaps months to dry. You can be with me. But under the sun, we are sure it might be 1 week depending on the temperature. And this longer duration of drying invites fungal growth if you don't really control the process very well, which most people hardly do. You invite fungal growth that decreases the content of this metabolite. In fact, we are gathering all the information regarding these post-harvest handling practices, and in the months ahead, we will do a publication which will show more other information for you to really grab.
I just
No.
no, it doesn't work. Okay, I have to. Okay, thank you.
Sorry. In the 130 Artemisia houses, so we dry Artemisia every day.
And under the sun, in our training, we train people to dry Artemisia under the sun to have this high mountain of artemisinin and 5-phytosterol. And very important, be careful when you dry under the sun, it can burn. You know, yes, so in some countries, the sun is very, very strong, and just don't just turn, yes, thank you, turn the material, and several times a day. And sometimes in 3 days, when the sun is very shiny, in 3 days it's okay. And you can also, it's very interesting because you can also dry big amounts of Artemisia, and it's very useful for people. And under the shade, usually it's fermented after that. Even mostly when it's the rainy season, it's terrible. And there's no artemisin after that.
In fact, thank you very much for that observation. Talking about fermentation, I also did not show that fermentation has a negative impact on the profile totally. In fact, once the plant is fermented, you don't even see polyphenols. It's, yeah.
So I was just going to ask you about all the other compounds, what the sun effect was when you answered it. You said that the other compounds go up in the sun.
Yes.
Yeah,
Yes.
yeah, that was my question. Thank you.
So, okay.
Thank you very much for the presentation. I was wondering, in your summary, when you were saying, you mentioned that the products are better during the rainy season than dry season. So I'm wondering why it should be so. Because if under normal circumstances, we have expected that the dry season products will have a higher amount of the artemisinin content than the rainy season products. Especially with your last statement now, where you said it's better to dry in the sun. So during rainy season, sun is even difficult to get. So these are contradictory statements. We have to please make us more clarity. Thank you. Thank you.
Yes, it's a tricky one, but I'm presenting to you the result that I have from the research. And we also did, if you read the publication very well, you will see that we did what we call the normalized different vegetation index value. And we saw that these values were, in fact, this value range between -1 to +1. And we saw that the closer these values to +1, it shows a healthier vegetation. And we noticed that, of course, normally we saw higher values in the rainy season as compared to the dry season, which corroborated with higher artemisinin content in the rainy season. Now, talking about drying under the sun, we don't need the sun to be maybe at 50 or 40 degrees or 100 degrees before you can have sunlight. Here, like this is still sunlight. So you don't need, even though in the rainy season we still have sunlight, you just have to be very careful when you are doing the drying process. I actually faced difficulties when I was doing this particular procedure because I actually dried also in the rainy season because I collected samples in the rainy season. So it's just for you, the handler, after harvesting, to be more conscious of your product. Yeah. In fact, I took 1 week off any other activity and concentrated on that because you don't want any single drop of rain from it to avoid any fermentation.
Merci pour votre
Last one, in
English.
In English?
In English, thank you for your good presentation, the good slides. But I think that it's not only sound who is good to dry Artemisia. It's a question of ventilation. It's the question of ventilation. If you put Artemisia in the shade, in the place where the air, how we call it, flow, you will have a good dry. it's not a problem of sun. In contrario, if it's a high sun and you didn't put your air bag in the paper, if you put in something like the soil or the nylon, how we call it in English, you will lose your production. The real problem is the ventilation. It's not sun. Do the experimentation again, please.
Thank you for your contribution. Let me just respond to you, please. Thank you. Yes, so the issue of ventilation stops fungal growth. That's the first point. If you don't ventilate very well, you have fungal growth, and then you have decrease in metabolite, including polyphenols. But for Artemisia annua, drying under the sun specifically increases the content of artemisinin because there is a particular reaction that is catalyzed by sunlight to convert the hydroartemisinic acid into artemisinin. This particular reaction is catalyzed by sunlight only. So in this case, you are sure of high content of artemisinin when you dry the samples under the sun and as compared to drying under the shade. There is another method of drying, which most people practice from my knowledge, oven drying at 40 degrees. This is better for polyphenols, but not for semi-volatile components. That's why in my conclusion, I say that drying under the sun is the best because it will maintain your volatile components, it will maintain